Hi everyone, my name is Sare Zeren Kelezoğlu. I'm a student in Industrial Engineering Department and I'm taking Physics 102 this year. And this video will be about my Physics 102 lab experiment. The aim of my experiment is to understand how the temperature of the cables in a circuit system affects the overall resistance of the system. And I will be using the materials such as a DC voltage source, a multimeter, a capacitor, a resistor, extra cables, because I'll be heating those cables, a laser thermometer, a stove, and the normal meter to understand how long the extra cable I will be using is. To conduct this experiment, I first set up a system where a DC voltage source is connected to a resistor, and then this resistor is connected to the extra cables I added to change the temperature of, and then these cables are connected to a capacitor, and the capacitor is connected parallelly to a multimeter. Other than the multimeter and the capacitor, all the other elements of the circuit system I have just said are connected in series. I used this system to find the resistance of the overall system practically, because if we calculate the time constant RC through the time that it takes for the capacitor to charge and discharge. I did that with taking the videos of how long does it take for the capacitor to discharge and charge, and calculated the RC with those videos. And so using that RC, since we know since we know the capacitor level, we can calculate the resistance of the overall system too. So this is how I calculate the resistance practically. And theoretically, I used some calculations mentioned in my project lab proposal paper, and calculated the resistance and RC through those theoretical theoretical values I had. And so after that, I will be comparing the practical and theoretical values in the end of the experiment for my error calculation. And I will also be comparing how does it take for the capacitor to discharge and charge, so how does it change the overall resistance in different temperature levels, which is what I'm actually trying to get in this experiment, like how the temperature changes the resistance. And those will be my comparisons and overall the aim of the experiment, I can say. Now I will be showing the video of my system, and later on I will be showing the discharging and charging videos of the capacitor in different temperature levels. The videos will be sped up, and before every discharging and charging video, there will be a temperature level photo, and that temperature will be the temperature of the extra cable. I will be trying to understand how it affects the resistance of the system. Now I'll be comparing the values. In theory, the little temperature change from 25 to 31, from 31 to 39, has actually changed the overall resistance a little bit, because it creates a resistor in itself with the cables. But when we round down or round up the values, we can't really say that the resistance changes. The change is really small, and we have to make really big temperature changes if we want to actually see a resistance change caused by the temperature. And in the results I got with the practical values, I believe I had so much errors because the multimeter was not working very well. When taking the videos, you could actually see that the multimeter was not showing the change in a consistent flowy way as it did in our experiment 3, which we had like different resistors and we were calculating RC. This time my resistance was really changing in like small values. Meanwhile, my RC was pretty much changing so much, so I couldn't calculate the resistance with the RC, although I calculated the RC. So I can say that there were many systematic errors caused by the multimeter and maybe the voltage source too. I'm not really sure about which machine works the best. And I can say that in practical, small temperature changes like this in cables don't really affect the system. Meanwhile, in theory, if I change the temperature too much, we can see that it would be effective on the system's resistance level. But obviously, I didn't get this result from the practical calculations. It was when I saw it in like theoretical calculations. And thank you for listening to me. This was all.